So far you people have already done like with one information that is given to you, how to determine the like volume or the mass or the number of moles of other reactant or the products, right? So now this is slightly different. Okay, here we will be given two data. Okay, like for example, if I consider let's say Fe2O3 plus CO, and that is giving us, let's say, Fe plus CO2, right? So 2Fe plus 3CO2. Yeah. So if we are having this kind of thing, yeah, and over here, if I'm saying that like this one is let's say 32 grams, and this one is let's say uh, so let's say this one is 12 dm cube, let's say, yeah, okay, this is 12 dm cube. So then how many grams of this will be produced, or how many dm cubes of this will be produced? And the thing is, over here you're given two data. Okay, one is 32 gram of Fe2O3, another one is 12 dm cube of CO. Now, which one to be considered as the basic, as the base with which like you will be determining Fe and CO? So in such questions, you need to first of all determine the limiting reactant. Okay, so there are some easy way of determining the limiting reactant. I'll tell you the steps, and then I'll tell you the solution also. Okay, so let's talk about the steps. So the very first step is convert the given data into number of moles. Convert given data into number of moles. Okay, that is the very first step. Second step is mask one of the data. Mask one data, okay, and determine the required number of moles of the masked data. Required number of moles of masked data. Now, I'll first of all I'll do the solution using the first and second step, and then I'll go ahead. So what did I say over here? First step is convert the given data into number of moles. We are given the mass of Fe2O3. What is the mass of Fe2O3? 32 gram. We can determine the molar mass of Fe2O3, that is 160. It is easily determined. Like you can actually just add the atomic masses, you get the value, right? I believe all of you are comfortable with determining the molar masses, right? All of you can determine the molar masses easily, right? So now when we have mass and molar mass, you know how to determine the number of moles. How do we determine the number of moles, guys? What is the formula for determining the number of moles?
Mass upon molar mass.
Mass over molar mass. Okay. Priya, if you are finding these things difficult, I would suggest you to go through the notes. Do you find these things difficult? Did you go through the notes? Did you go through the recordings?
Yeah, I did.
Very good. Shabash. So we are having a mass that is 32, molar mass that is 160. So what is the number of moles, guys?
0.2.
0.2. So we got number of moles of Fe2O3, 0.2. Similarly, I'll determine the number of moles of carbon monoxide. Okay. So we are given the volume of carbon monoxide, which is 12 dm cube, right? So what is the number of moles, guys? What is the formula for the number of moles? Volume over
Provided upon total volume. Means upon 22.7.
22.7. Yeah, the volume should be in dm cube. This is the formula, right? So what is the volume? Volume is 12. This is 22.7. Guys, can you tell me what should be the number of moles over here?
0.53.
Yeah, 0.5.
No, it's
0. So number of moles of CO is 0.53. Right? All of you agree? Yeah?
Yeah.
Now, the second step is mask one data. So guys, please tell me which data should I mask? Either Fe2O3 or CO. Please tell me which one. Choose one.
mask means what does
Mask
mask
means
mean?
like we ignore. Okay, we ignore that. Like we consider that like it's not given only. Okay,
Oh, so the carbon monoxide one, because that is an Fe2O3 has an easier number to get multiplied with 0.2.
Shabash. So let's mask this thing. Like let's consider and like we are not given CO at all, right? So if you think this way that like CO is not given at all, so you will definitely try to determine the required amount of CO, right? By comparing Fe2O3 with CO. The ratio is 1:3. So this is 0.2, and how much this should be? Then in that case,
0.6.
0.6
moles.
moles. Now this is the required amount and this is the
Yeah.
given amount. 0.53 is the given amount and 0.6 is the required amount. So there comes the third step. There comes the third step. If you are given more than required, then it is considered to be excess reactant. If you are given less than required, obviously just understand my sentence. It's very simple sentence. If you're given more than required, obviously that means you're given in excess. And if you're given less than required, then that is known as the limiting reactant. Okay. Easy. So we got the. So now please tell me what is CO over here. Therefore, what you can say CO is, what is it? CO
The
is,
limiting reaction.
for CO,
Yeah.
you are given less than required, right? When you are given less than required, it is considered the limiting reactant or limiting reagent. So CO is LR, limiting reactant. And therefore, we can say Fe2O3 is excess reactant. Okay. You are given more of Fe2O3, less of CO. So guys,
Yes.
so far everything is good, right? Everything is clear,
Yeah.
right? Now the
Yes,
final
sir.
step. Now the final step is make the limiting reactant as the basis. Okay, limiting reactant becomes basis for other calculation. Basis for other calculation. Okay, what do you want to determine here? We want to determine Fe. Okay, so I won't be comparing it with the Fe2O3. I'll be comparing it with the limiting reactant, that is CO. So Fe will be compared with CO. This is 2, this is 3. So, but this is 0.53 given. So what this should be? Please tell me what should be the number of moles of Fe, guys?
1 second. 0.353. 0.35. 35.
Are you sure?
Yeah, 0.53 into 2 divided by 3, right?
Correct.
0.35.
But isn't the moles of Fe1?
It's
Acha,
2.
0.35 you're saying, right? That's
Yes.
correct. Yeah, that's correct. That's correct. So 0.35. So with that, you can determine the mass of Fe. Formula is
Yes.
number of moles is mass upon, if it is the atom, so it is the atomic mass. So mass of Fe will be, atomic mass is 56. Let's say number of moles is 0.35. So you will be getting the mass of Fe over here in grams. You got it, right?
Yes, 19.6.
And the volume of CO2 will be, since it will be having the same moles, you see the ratio is 3:3. That means same number of
Yes.
moles. That means even that will be
Yeah.
0.53. Okay, so it will be like 12 dm cube only. Okay, I
Yeah.
hope this is clear. So I hope this
Yeah.
entire explanation is like clear to all of you.
Yes,
But
sir.
anyone having any doubt? Anyone? Please tell me. So here is the question. Question is NH3 reacting with the uh, 2 NH3 reacting with the 2 to form NH2CO NH2 plus H2O. So ammonia reacting with carbon dioxide to form urea. This is urea, guys. Okay, NH2CO, NH2. That's the urea and water. Yeah, this is the thing. This is the reaction. What you're given is you are given 5.1 gram of this thing. Okay, and and 3 dm cube of for this thing, and you have to determine how many grams of this thing is formed. Okay, first you determine what is the limiting reactant, and then determine how many grams of this one. All right. What you are given further is the atomic masses. Nitrogen is 14, hydrogen is 1, obviously. Yeah. Then carbon is 12, and oxygen is 16. So these are the atomic masses. I'm giving you 5 minutes to solve this thing.
0.3.
0.3.
What is the number of moles of NH3, guys? 0.3.
0.3.
Then what number of
0.3.
moles of CO2 you got?
0.13.
1.3.
0.13. Which one did you mask?
CO2.
0.13 I am asked.
All right, so let's mask that one. So let's mask this one. So when we are masking this one, so you must have determined the this is the given number of moles. So you must have determined the required number of moles of CO2. What is the required number of moles, guys?
0.15.
0.15. Okay. So what did you estimate using this thing? Which one is the
That's
limiting
CO2
reactant?
is the limiting reactant. CO2.
Yeah.
CO2 is the limiting reactant, and NH3 is the excess reactant, right? So with that, you must have determined the number of moles of NH2CO, NH2 produced, right? What is that,
Yes.
guys?
0.13.
Shabash,
0.1.
0.13. Okay, so with that, you can easily determine the mass of urea produced. Was it?
Yes, 7.8 grams.
0.8 grams.
All right. Now, here is another part of the question. Determine the mass of NH3 unused. Okay, please determine that quickly. Okay, so guys, what is the mass of NH3 unused over here?
I got 6.8 grams.
I got 0.68 grams.
Who got 6.8 grams?
Sorry, 0.68. Sorry.
Out of 5.1, like 6.8
Sorry.
grams.
I placed the decimal in the wrong place. Sorry.
All right.
0.68.
So this is 0.68 grams. All of you got this thing? Anyone having any problem, any doubt anywhere? Please ask.
Sure, do we have to round down the answer?
You can, but like do it like mostly up to 2 decimal places. I'll teach you that rounding off also later. Okay, not right now. So I hope this whole thing is clear to all of you.
We'll have to round off till 2 dp, right?
Yes. Okay.
Okay.
Yeah.
Okay.
So guys, I hope this is clear to all of you. Anyone having any problem anywhere? No? Chalo, one more question. Here we are doing one more question now. So the question is, C2H6 plus O2, and that is giving you CO2 plus H2O, right? Then when we balance this, this is 2, 3, 2 are 4, 3, 7. So 2, and this is 7, then 2 is 4, and this is 6. Yeah, this is the balanced chemical equations. Now this one is you are given this one to be, all of these are gases, by the way. All are gases. Okay, all are gases. Now this one you are given this one is 40 cm cube. Then that is 150 cm cube. Okay. What you have to determine is how many cm cube of this will be formed, how many cm cube of this will be formed, and also one more thing, what is the total volume of the gases, total volume of the gases in the container at the end of the reaction, at the end of the reaction. Okay, yeah, this is happening in a closed container. Okay, this is happening in a closed container. Chalo guys, please do this. I'm giving you 5 minutes. Come on.
I did not moles.
One more thing, guys. Wait a second. One more thing, guys. Since all of these are gases, okay, we can actually skip that step of converting it into the number of moles. You can only just deal with the gases only, just with the volume. Okay, we can take the stoichiometric ratio as the ratio of volume also. Okay, so basically, so what we will consider, let's mask one of them. Okay, so which one you want me to mask? Ethane or oxygen? C2H6 or O2?
O2.
Chalo, let's mask O2. So this is the given volume. Okay, this is the given volume. All right, so I'll determine the required volume, C2H6 versus O2, 2:7. This is 40 centimeter cube. So how much this should be? So that will determine. So what is the volume of O2 with this?
We 40 into 7 divided by 2, so 20 into 7, 140.
140 centimeter cube. This is the required amount. You are given 150 and you require only 140. Okay, this says that C2H6 is the limiting reactant. Okay, one more thing, out of 150 only 140 is being used, right? That means O2 is the excess reactant and 10 centimeter cube O2 of O2 will be left over, at the end of the reaction. Agree?
Yeah.
You will be making C2H6 as your basis because that is the limiting reactant. So when I compare C2H6 with CO2 and C2H6 with H2O, the ratio is 2:4, here 2:6.
Yes.
So if this is 40, then how much this should be?
80.
80 centimeter cube
Yes.
is 40. So how much this should be?
120.
120 centimeter cube. Yeah. So, well, in that case, so total volume, the total volume will be equal to 10 of O2 plus 80 plus 120. What is that?
210.
110.
Correct.
Yeah, I
Got
got
it,
it right.
Okay. So see, guys, it's not difficult, right? Was it
No, sir.
difficult? Damn easy.
No.
Okay.